it's a great environment for, learning and applying the, knowledge, and also working with your hands if you're running machines. And
Yes.
but seeing how it was such a rewarding career for my father, and then it's been such a rewarding career for me. That's what really inspired me to move away from the big corporate organization like General Dynamics, and then do things for these not-for-profits that we can help the small, medium manufacturers. And that's sort of been my passion now for the last 15 years.
Hi, everyone, and thank you for listening. I'm your host, Kerrie Jordan. Welcome to our show where we talk with industry experts driving the future of manufacturing. Today, I'm speaking with Dr. Dean Bartles, who is a highly accomplished, seasoned operations professional currently serving as the president and CEO of the Manufacturing Technology Deployment Group, a not-for-profit holding company of both the National Center for Defense Manufacturing and Machining and Advanced Manufacturing International. He has held several executive and board member leadership roles in organizations such as National Tooling and Machining Association, the John Olson Advanced Manufacturing Center at the University of New Hampshire, the Digital Manufacturing and Design Innovation Institute in Chicago, and UI Labs. Dr. Bartles also worked for General Dynamics Corporation for 30 years in global manufacturing leadership roles. This is just such an incredible opportunity to speak with you. I am so looking forward to this conversation. Dr. Bartles, welcome, and thank you for joining the show.
Thank you very much. Happy to be here.
Well, first, you have such an impressive background in manufacturing and technology management. Would love to get to know more about you. Could you tell us about yourself, your background, and your current organization, and what drives you to accomplish so much?
I was very fortunate. I grew up in an environment where I got exposed to manufacturing at a very, very young age. My father had a welding and machine shop in Hagerstown, Maryland called Bar Welding and Machine. It was just a one-man operation. He occasionally would take on an extra person to help him with different jobs. But I kind of grew up in my father's shop. From the time I was 8 years old, I learned how to run a bandsaw and saw pickets for one of our iron railings. And eventually he exposed me to welding and machining. And when I graduated from high school, I actually took a job as a machinist at Grove Manufacturing in Shady Grove, Pennsylvania. But then I went on to college, and once I finished college, I got hired by a Fairchild Republic company that made the A-10 airplane in Hagerstown, Maryland. Got hired on as an industrial engineer. I was doing time studies initially, eventually transferred to the program office, and worked there for about 5 years before I got recruited by the company that became General Dynamics. When I first got hired by them in York, Pennsylvania area, it was called General Defense. No relation to General Dynamics, actually. But I was hired specifically to set up a manufacturing line in Egypt to make tank ammunition. This is a program through the U.S. government. Did that for about a year, and then we did almost the exact same thing with the government of Turkey. So got to travel internationally, and eventually grew up to the ranks of the corporation. We were acquired and then spun off and then acquired again, eventually becoming a General Dynamics company. When we did become a General Dynamics company, that's when I was given a chance to take over several manufacturing operations. One of them was Scranton Army Ammunition Plant in Scranton, Pennsylvania. That's been in the news lately because they make artillery shells, but also facilities in Redline, Pennsylvania, and Joplin, Missouri. So it had a really rich history of the manufacturing and advanced technology type stuff. But my big change came, I call it my encore career, after 31 years with General Dynamics and 36 years in the defense industry. I was recruited by this new not-for-profit in Chicago called UI Labs. And UI Labs was formed to set up the Digital Manufacturing Design Innovation Institute, which was the second of these Manufacturing USA institutes. There are now, I believe, 17 institutes that have been stood up by the government. But it was such great fun standing at the institute up, working for Dr. Carolyn Collins there in Chicago. We recruited over 300 members, and that became my passion. What we could do to deploy advanced manufacturing technologies to help the small, medium manufacturers. The big corporations that have plenty of money, they've embraced Industry 4.0, but for the small, mediums, I wanted to figure out how could we help them. So doing that through the institute, and then also doing it with the University of New Hampshire, where they had received a $5 million gift, and they called me and asked me if I'd come up and set up an advanced manufacturing center there, which I did. And then I got recruited by the National Tooling Machining Association, as you mentioned, to be their president and CEO. And that eventually led me to the job I've taken now. I've been with the company for about 5 years. I'd served on the board for about 10 years before that. And the founding company was called the National Center for Defense Manufacturing Machining. Once I took it over, I decided to create this parent holding company that I call the Manufacturing Technology Deployment Group. Along with that, we created this subsidiary, Advanced Manufacturing International. And the focus of AMI is to help the community colleges obtain state funds to build out their advanced manufacturing labs. So here in the state of Florida, for example, there's over 20 community colleges that offer these 2-year engineering technology programs, but they still have pretty much your basic bridge ports and welders and things in their labs. And we're trying to give them some of the more advanced technology like 3D printing and AR, VR, that kind of thing. So it's been a real exciting career, and that pretty much is my whole life that I've just explained. So
yes. And can I ask you a little bit more about that? What is it about manufacturing that kept you coming back?
Well, yeah, because manufacturing is such a great field that provides people the opportunity to, work their way into what you might consider the middle income ranges and then beyond, really. It's a great environment for, learning and applying the, knowledge, and also working with your hands, if you're running machines. And
yes,
but see how it was such a rewarding career for my father, and then it's been such a rewarding career for me. That's what really inspired me to move away from the big corporate organization like General Dynamics, and then do things for these not-for-profits that we can help the small, medium manufacturers. And that's sort of been my passion now for the last 15 years.
And can I ask you more about your PhD?
Sure.
What did you get your PhD in, and why? What was the decision behind that?
Yeah, so I had, secured my MBA part-time when I was working at Fairchild Republic Company. And then when I moved to Florida, I took up a second master's degree in international business. And I was doing a lot of international marketing for General Dynamics Corporation after setting up these manufacturing plants. But, the defense industry in the early 90s took a pretty draconian turn and started, really reducing the size of companies, and lots of people were getting laid off. So I decided to pursue a doctorate in case, maybe I would get laid off, right? And I thought I could teach. So I did this part-time while I was working full-time for General Dynamics, and I was able to secure my doctorate in business administration initially. And that took me about 9 years part-time while I was traveling all over the world. But then, lo and behold, no sooner do I finish my doctorate in business when I was given this opportunity to run a strategic business unit in General Dynamics that included 3 manufacturing plants reporting to me. So I wanted to learn more about advanced manufacturing technology. I figured, how could I challenge the plant managers at these plants that reported to me now and sort of challenge them to embrace newer technologies if I didn't know all the options myself. So I found this PhD program in technology management with a concentration in manufacturing systems through Indiana State University. And the program was a consortium-based program where they had, I believe it was 5 different universities that you took courses from. All of this was online. There was a residency requirement one semester to, attend courses there on campus, but everything else was online. I took courses from Bowling Green and East Carolina University, North Carolina State University, and it was a challenging, rigorous program, but I learned a tremendous amount about some of the more advanced manufacturing technologies that I wanted to deploy in my own shops. So I finished that program. That one also took me, I think that one was 10 years, doing it part-time, but finished that in 2013. And every time I've taken courses, these advanced courses, it's really helped me in my job. I learned so much, of what's sort of the cutting edge, state of the art, and then able to apply that in my own manufacturing shops has been extremely rewarding. So I've always encouraged people, if you want to advance, if you like to learn, this is a great way to do it, especially if you work for an employer like I did that offered a college reimbursement type of program where as long as you made an A or a B, you got your money back. So it was great, a great motivator.
That's excellent. Yeah, thank you for sharing that with us. I mean, it's really interesting. I was curious, would it be applicable? And absolutely, of course it is. And it's interesting too, because what your organization now does in your role today, you mentioned does work with universities and colleges.
Yeah, in fact, we run the very first one of the Manufacturing USA Institutes. It's the National Additive Manufacturing Innovation Institute, which is branded as America Makes. So NCDMM is the company that manages that program in conjunction with the Air Force. And we have, about 20 different universities and colleges that are members, along with a couple of hundred companies. But each one of these Manufacturing USA institutes are focused on maturing the technology. So we're not doing anything that you would consider basic research, sort of the technology readiness levels 1, 2, 3, but all these institutes are focused on technology readiness levels 4, 5, 6, and 7, which, that's kind of considered the missing middle, sometimes referred to as the valley of death, where all good basic research goes to die. But this is applied research and getting that technology into the hands of companies that can then take it all the way to TRLs 8, 9, and 10, which is commercialization. So we've been running America Makes now for about 12 years. Like I said, it was the very first one of the institutes. We think it's been very, very successful. We continue to get companies that want to join and get involved. And the universities have been a critical part of that, because the academicians that apply for some of the grants to be able to take and do research projects and mature the technology has been extremely helpful. So yeah, I love working with universities. I've been on, no exaggeration, probably a dozen different advisory boards over the last 20 years of different universities. I'm on several right now. And I just truly enjoy working with the academicians as well.
What an interesting aspect of just visibility into what's happening across, manufacturing as well as within the university arena. What are some of the trends that you see, things coming and going? What's happening now? What's coming next?
Yeah, well, in fact, usually a good way to tell what's coming next is to keep track of these institutes, because the government is going to put more of these institutes up. And they just came out with the latest announcement, and it's no big surprise here. They call it AI for resilient manufacturing. So, AI is the hottest thing right now. Back 12 years ago, when they first started this program, additive manufacturing was the hottest thing. And additive manufacturing is still pretty hot. But now it's all about AI. So there's going to be a new institute, yet to be determined who will win that program. It'll be competitively bid. Okay. But it's going to focus on this artificial intelligence for resilient. Now that's sort of the buzzword of 2024, where, the resilient manufacturing, resilient supply chains. How can we make our supply chains more resilient? One thing that everybody seemed to learn during COVID is, oh my goodness, maybe our supply chain is not as resilient as we thought it was, because so many countries, had much more strict rules than what the U.S. had. And it really was a major interruption in the supply chain for so many manufacturers. So now there's a big move to bring back manufacturing here to the United States. They call it reshoring, and sometimes it's referred to as nearshoring. That's a big move right now. And more companies are embracing that, which is great, of course, for the United States. But I happen to think that additive manufacturing is going to be a tool that companies are going to use to bring some of that manufacturing back. The nice thing about additive manufacturing is the investment, to get involved in additive manufacturing is not as significant as what is referred to now as subtractive manufacturing. It's not quite as capital intensive, and you don't really need to have a lot of specialty machines to do things, because you can 3D print, parts that have inner working parts out of one print. I mean, it's really fascinating technology. And more materials are coming online for additive manufacturing, with composites and ceramics, and not, of course, metals are really, really big right now with laser cutter bed fusion. But that is still a very, very hot emerging field that's going to be continuing to mature for years to come.
And if you wouldn't mind, speaking of teaching, for those listening in who might not be familiar with additive versus subtractive manufacturing, would you just, briefly speak about both?
Sure. So subtractive manufacturing, which, is a term that people started using once they started calling additive manufacturing additive, right? 3D printing, right? Mm-hmm. Subtractive, you might start with, like bar stock, say a 20-foot length, 3-inch diameter bar that you would feed through a lathe, and you remove material to form the shape that you're trying to end up with. Whereas additive manufacturing, you typically start with, I'll use laser powder bed fusion as an example. You'll start with powder, metal powder that's spread across a real thin layer on a table inside of a chamber, and you hit it with a laser. The laser will melt the powder together of a specific pattern that you fed into the machine based on your CAD design. And then the table lowers a little tiny bit, another layer of dust is added, and you repeat that process. And you continue to do that hundreds of times until you build up the part and make this shape that you determine a priori what shape you would want to build. So additive manufacturing is really taking over. Now, it's never going to replace subtractive. There's a lot of things that, extremely high volume production, for example, like when I worked for General Dynamics, we were making 100-pound artillery shells, and you might want to make 10,000 a month. I don't see additive ever doing that. But General Electric, which has invested billions of dollars into their additive manufacturing technology, they're making engine parts for their jet engines, which is, you don't make a whole lot of jet engines every year, obviously. But so low volume, complex parts, one of the expressions you hear about additive is complexity is free. It's not really free, but you can do complex designs and additive that you can never do with subtractive. Lattice structures, for example. Yeah, both of them are, still fields that continue to improve all the time. And you see them now, they're starting to merge. It's called hybrid machining, where you not only do subtractive, but you do additive on the same machine tool. So that's a new area that's emerging as well.
That's great. And I could see how it would really depend upon your type of business, what it is that you're building, that would influence whether or not you would choose one or both. Can I get your take on AI? What do you think its role is in resiliency in manufacturing?
Yeah, so one of the areas that AI, I think, is going to have a big impact very, very quickly is in the area of predictive maintenance. For years, companies have been doing, something called total productive maintenance. And basically, that's where you will do preventative maintenance based on perhaps the amount that a particular machine is being used, right? I remember when I first walked into one of the plants that I inherited when I took over this job at General Dynamics, and I asked the maintenance manager, well, how often do you change, let's say, the oil on machine A? And he would say, well, we change that every 3 months. Okay, well, how about machine B? Every 3 months. Well, what if machine B is used twice as much as machine A? But that it's sort of like changing the oil in the car. You do it every X number of months, regardless of how many miles. At least some people do, right? Mm-hmm. But now predictive maintenance is different. So predictive maintenance is when you're sensing things going on the machine. It could be vibration, it could be temperature, it could be acoustic emissions. And artificial intelligence is going to be able to discern patterns that humans aren't really capable of discerning that quickly. So with artificial intelligence, once you have a baseline and you have the algorithms applied to the baseline, you'll be able to detect changes and be able to predict, okay, maybe we should change out that bearing or that ball joint before it fails. And we want to do that on the weekend and not interrupt first shift production during the week, which is your highest, performing production time. So I think AI is going to have a big impact on that. Another area that AI, I think, will have a big impact on is designing new materials. So there's a field called integrated computational material engineering that's being deployed now in order to design materials, and not just materials, but also processes. For example, in laser powder bed fusion, the key to achieve, the kind of mechanical properties that you desire is the parameter settings. And you can have variability with the laser beam energy, the scanning speed, the spot size. There's so many variations. And in order to achieve the absolute best mechanical properties that you want for a particular part, you can now a priori put all that into a model and do this simulation and be able to determine this is the exact scanning speed or the exact laser energy power or the exact spot size that I want to use in making my parts. So integrated computational material engineering is going to have a huge impact on new materials that are being developed, as well as the processes deployed in making parts.
You just made me wonder, as a student, somebody who's thinking about going into this field, or perhaps somebody even mid-career looking to go back to school, where would you recommend that they focus their studies?
I happen to think that if you can find courses that are specific to advanced manufacturing technologies, and believe it or not, at some of the community colleges, there are courses that you can take in the evenings that do exactly that. So it depends on how hungry you are for knowledge, right? If you want to do something like I did, it took me, like I said, 9 years in order to finish a program. But, a big part of that was because I just wanted to get the degree, right? So you don't have to have the degree, you could, I could have taken all the courses that I took and stopped and not written a dissertation and still had just as much information, that could have advanced my career and information that I could deploy real time into my job and in my manufacturing plants. So there are courses out there that, one thing about manufacturing, you don't really find that many seminars, right? The seminars that are typically for accounting and IT, human resource type things, but to find the courses in advanced manufacturing technologies, you really have to find courses at colleges. So, whether they're community colleges or whether they're four-year institutions, there's a lot of great courses out there that you can take. And, I'm a huge proponent of learn. You've heard salespeople always talk about ABC, right? Always be closing. And I've always said it should be ABL, always be learning.
Yes.
So my whole career, I've supplemented my on-the-job knowledge with taking courses and learning new things. I majored in business undergrad, but now I'm considered this manufacturing technology expert because of all the learning that I've done during my career, both deploying in manufacturing and managing manufacturing operations, but also in the courses that I've taken to supplement my learning.
So then from the other side, somebody who's already in, running a business, perhaps running a small to medium-sized manufacturing business, when you're working with those kinds of organizations, what challenges do you see them facing that you help to coach them through?
Yeah, the biggest challenge that every small, medium manufacturer has today is they cannot find skilled workers. It is the number one problem. And I hear from so many owners of small businesses that, it's not just finding skilled workers, it's finding workers.
Mm-hmm. I hear that too.
Yeah, finding people who are committed to show up every day. Let's say your shop runs typical, let's say 8 to 5. Okay, to find people that are willing to show up on time every single day is a real challenge. Yeah. And then to train them up and get them the skills that they need to be productive employees is also a real challenge. So we do a lot of partnering with Tooling U. Tooling U is a company that's owned by SME, which used to be called the Society of Manufacturing Engineers. They just go by SME now. And Tooling U has, oh my gosh, they must have over 800 different online courses that people can take in the evenings or even during the day if their employers would allow a certain time for that, where they can get, some of these new skills, skills in AR, VR, and just pretty much all types of manufacturing. So we do a lot of partnering with them. Each one of these Manufacturing USA Institutes offer training in their different fields. So, of course, America Makes, we offer a lot of training in additive manufacturing. So there are opportunities out there to upskill for people that are currently working, and you just got to, take advantage of it. If you want to advance or if you want to do something different, if you want to learn skills because you're not happy with the current job that you have, there's ways to do that. You have to seek them out. And we try to do that. In fact, AMI, like I mentioned, they're focused on helping community colleges with not only curriculum development, but also obtaining the types of equipment that they need to put in their labs to train up students. And a lot of the students at community colleges are people that are sort of already in their careers, and they may be working in one field, but they want to change and do something different. That's why the programs are so great. That's why we decided to focus on helping them.
That's great. I mean, like you, I hear that so often. So it's wonderful to hear that there are those kinds of programs that you're making available. Excellent. Another question I wanted to ask you is kind of going back to technology. On this show, we're always so focused on technology in manufacturing. What other kinds of technologies have you seen at play? We've talked about some of the methodologies and the tools to support subtractive and additive AI. What other kinds of technologies are you seeing?
Well, AR, VR is sort of still an emerging technology in manufacturing. When you think about all of us during COVID and now post-COVID as well, we've really embraced the meeting that you and I are using right now, right? We've embraced Zoom and virtual meetings.
Oh, yes.
But now in manufacturing, as we're faced with what some people refer to as the silver tsunami, which means, all the people my age are starting to retire, right? And you've got a lot of knowledge that's walking out the door. And the younger people that are coming into some of these jobs, in order to make them more productive, well, now they can wear, sort of like Google glasses as an example, and they can be disassembling a machine that needs to be fixed, but they can also be showing what they're seeing real time to someone who's got, 40 years of experience, but doesn't want to do the traveling anymore. So they're at home and they'll dial in and call up and they'll be able to see exactly what that younger person's working on and be able to tell them, here's what you need to do next. You need to remove that piece. You need to remove that piece. I mean, I remember my father when he was working for a company before he started his own business, his job was fixing printing presses for, companies that did bookbinding. And he had to train younger people all the time. In fact, he was training one younger person while he was trying to fix a machine. And he would tell the younger person, okay, now you got to bump the machine to move this, this big roller. Okay, now bump it again. Well, lo and behold, the young man bumped it without my father saying bump it, and that took his hand right through the roller. So you got to be careful with that kind of
yes.
stuff. But now with AR, VR, it's really fascinating that you could sit at home as I am right now, and you can be looking exactly and seeing what the younger person there is working on to try to fix something and be able to guide them and tell them, here's what you want to do next. Here's what you want to do next. Also for inspection, so there's a lot of buzz out there in the media right now about the lack of inspection on certain things. You hear about bolts missing, et cetera, right?
Uh-huh. Yep, heard that.
Yeah, so now, you can have this AR VR component where when you do your final inspections, you actually use like an iPad and you take a picture that you did in fact inspect that, and big check mark there and go to the next thing, right? So there's companies that are using that already, and the quality to make sure that all inspections have been completed is much, much higher because you can't cheat. You got to have a picture of that final inspection of that particular operation using that kind of technology. So yeah, I think it's going to become more rampant and you're going to see more and more of it out there in the manufacturing side.
I agree. All right. So what kind of advice do you like to give maybe somebody who is at the beginning of their operation, leveraging technology, trying to think through what is the right technology for me? Maybe they're dealing with those kinds of challenges around qualified workforce and finding the right talent. What kind of guidance or advice do you give?
Yeah, a couple things. And I did this probably later in my career than I should have. But number one, get involved with a couple of professional organizations. Because the networking will pay huge dividends. That's really why the Society of Manufacturing Engineers, now called SME, that's why they were formed back, almost 100 years ago. I think they celebrated their 90th recently, but originally they were called tooling engineers. And even the word engineer, these were tooling engineers back then were people that could actually, chase thread on a lathe, which of course now it's all done with computer numerical control, but they wanted to network and they wanted to learn from each other. So they formed this organization. Well, that still applies today, even though so much of it might be done on like LinkedIn and Zoom. Just get involved with a couple of groups and don't be afraid to ask questions. That has really served my career extremely well. My willingness to ask stupid questions, because there really isn't any questions that's stupid. But so many people are afraid to ask because they don't want to appear stupid. I say, heck with that. Ask your questions. Always be inquisitive. Always ask, especially the people that have 20 more years experience than you do. Ask, ask, ask. Also, I would encourage people to, get involved in reading some of the academic peer-reviewed journal articles. There are so many great research programs out there that are always reporting out on these academic peer-reviewed journals. There's a couple of annual meetings that where you can go and hear cutting edge research results from some of these academicians. One of them is called NAMRAC, the North American Manufacturing Research Conference, which is put on by NAMRI, the North American Manufacturing Research Institute, which is a subdivision under SME. But every summer, coming up in June here, it's going to be at the University of Tennessee, Knoxville this summer. It's like a 4-day event. And there's probably 8 different tracks of advanced manufacturing technologies. And each one of those tracks will have, 5 or 6 paper presentations every day. There's so many opportunities to find out what's really cutting edge future that may not be deployable today, but it's going to be coming down the next couple of years. And you want to be aware of these advanced technologies. So I would encourage people that even if you have to take vacation time, which is what I did often, to go to one of these conferences a year where you can really get exposed to some of the more advanced technologies. So, get into a couple of journals and read these articles occasionally. Go to an annual event like NAMRAC and network. I can't emphasize that enough. That has paid such huge dividends for me in my career. So I try to encourage, my three sons and other younger people. This is how I've been so successful. I really encourage you to do the same thing.
ABL, always be learning, right?
ABL, absolutely.
That's great. Well, this has been such a great conversation. As we wrap up here, what final thoughts do you have that you wanted to pass on?
I would like to just encourage anyone listening to this. Manufacturing is such a great career path, and the country needs you. I know that might sound corny, but it's really, really true. The country needs you. I mean, there are so many unfilled manufacturing jobs today. I will tell you, the defense industrial base needs you. They're talking about ramping up to 3 submarines a year. In order to do that, they need over 1,000 skilled workers, to fill these jobs. And you might see some of these commercials now on TV where they're talking about building giants. It's the submarine industrial base. So that for younger people that are looking for a very rewarding career, by the way, a very high paying career, I can't encourage you enough to take a look at manufacturing, because it's not your dumb, dark, dirty, dangerous field anymore. It's exciting. It's modern. It's advanced. It's clean. It's safe. And there's so many new technologies that you will find so interesting and challenging. You'll never regret it.
So much opportunity.
Yes.
Absolutely. Well, this has been such a great conversation. For anybody who wants to learn more about Manufacturing Technology Deployment Group or to connect with you, where would you direct them?
Yeah, www.mtdg.org. And my information's on there as well. I'm happy to reach out and help anybody. I'm also on LinkedIn. You'll see me posting on LinkedIn every week something about advanced manufacturing technology.
Excellent. And we'll include the link in the show notes. Thank you so much, Dr. Dean Bartles. This has been such a great conversation.
My pleasure. Thank you.
Well, that was my guest, Dr. Dean Bartles, currently serving as the president and CEO of the Manufacturing Technology Deployment Group, a not-for-profit holding company of both the National Center for Defense Manufacturing and Machining and Advanced Manufacturing International. And to everyone listening in, thank you so much for being a part of the future of manufacturing.